introducing Professor Hans Güdel. After we will have the pointer work. Then Hans Güdel is well, he's a very good friend. He has been here for many times. During every year he's coming in May or June to be with in the institute and to discuss with the people in the institute, in particular with the people of my group. Well, he's doing always very good advices. Now he's retired several years ago already, but he's also giving talks that are more about, not about science in that case, but about policies in science also, but about how the scientists should be, which are the problems, because he has been also in charge in Bern of this kind of problems. Then he's having, well, he can explain what he was doing in Bernard's activity, but was an activity in which he has to solve some problems that can exist when several scientists are acting not in a good way or are having problems among them. Then these kind of activities are also activities that are needed in the universities, and then in Switzerland they have this kind of possibility. Here in Spain, in the university, we don't have this kind of figure. But well, in Switzerland it seems that they like to have this kind of figure that can be useful. Then today he is going to talk about that, about this kind of problems that you can have in science, these behaviors in science, and then, well, we are filming what he's saying, and anything is confidential from this point of view, except the problems with the University of Bern, perhaps, but in any case, I am happy that everybody is here, and not only people from our institute, but also people from other institutes, and also from physics. I think that is a talk that is interesting. Well, you know him, he's an interesting person, that's why everybody's here also. No, it's good, you know him for a long time ago, then, in that case. It's one of the talks in which much more, well, the maximum audience is having, is staying here. Okay, thank you.
Okay, thank you. I'll try to get up here. Okay. Seems to be a popular subject, the cheating. It's very nice to have such an audience. Thank you very much. Well, lying, cheating, deceiving, misrepresenting, manipulating, obscuring, disguising, fudging, faking, bullshitting. All these are part of everyday life in politics. In science, however, we are setting high barrier to such activities. Reliability and trust are considered paramount. When they get lost, we can pack up. And that's why we should care when scientists are cheating. Of course, there is an element of elitarian arrogance in this statement. It implies that our ethical standards are higher than those in everyday life. And that's why I think this should be not just a statement, but a commitment to us, every one of us, universities, funding agencies, journals, academies, societies, the media, the public. Now, as Eugenio mentioned, I had a job as Scientific Integrity Officer of the University of Bern for 8 years after my retirement as a chemist. And some of what I'm going to say is based on these experiences, even some cases from that time I will present. What I'm not going to do is give you a treatise on scientific integrity. Rather, I've chosen a few examples which I think are relevant. the emphasis will be on the misconduct on the one hand, but also on the way we are dealing with it, on the way a university is dealing with it, or journals are dealing with it. And now let's see whether this works. Yes, it does. I'll give you a couple of examples only on plagiarism. The emphasis will clearly be on this, also some examples of data manipulations down here, because these are by far the most important misconduct cases in the natural sciences and in the life sciences. So, plagiarism, you find a lot of examples on the internet on plagiarism. I have selected just 3 of them. The concept that of having a copyright to what one wrote down, of the ideas one had, is rather new. 2,000 years ago, this fellow Marcus Fabius Quintilianus, he was quoted as saying that the more there is of a good thing, the better. So imitate, imitate, imitate. And then the idea that this was not so good came only later on. Now, this gentleman, you all know his name. He did his PhD thesis about 70 years ago, and in the early 90s, it was found that about 1/3 had been copied from somewhere else. If we use today's criteria, today's practice, this is not acceptable. But we would make a mistake in judging this thesis on today's criteria. It has to be judged on the basis of the practice used 70 years ago in theology at Boston University. So we would have to take, let's say, a dozen or so theses and find out what was the practice. And I would not be surprised if what Luther did was common practice at the time. So one should be careful to judge not on today's practice, but on the practice at the time. Now this lovely lady here, she was playing the piano. She was playing the piano reasonably well, but she was not a master. But her husband, he was a master. He took recordings of the big masters of the piano and manipulated them electronically, all in the same way, and then put them on the market as pieces played by his wife. And that's blew up 2012. That's real plagiarism. It's an example outside of science. And now an example between science and politics is this gentleman here. I give you a few seconds to read his name. It's about 10 years ago he submitted a thesis in Bayreuth in Germany in the law faculty, and a few years later he was defense minister of Germany when it blew up. One of these plagiarism hunters, he had found out that most of it was copied. Here, the pages, that's scanning the thing, letting the thing through an anti-plagiarism software. The blue parts are the introduction and the references. And the white ones are pages without any plagiarism. The black and the red, they contain one or more plagiarized part. Now, the interesting thing here is that at that time, such a thesis was still submitted to a faculty, and that nobody in the faculty noticed anything. He got a summa cum laude for his thesis from his professor, who probably never read it or even looked at it. At that time, all these programs were already available 10 years ago. And therefore, it's really astounding that the faculty at the university, renowned university in Germany, can let such a thing through. Well, Gutenberg, he lost his job as defense minister. He left Germany for a few years to the US. Now he's back in politics in Bavaria. We will hear from him. Now, these are the examples about plagiarism. For the natural sciences, for our field, plagiarism has never played an important role, and it never will. I think overall it's a transient phenomenon, because comparing a sequence of words is such a trivial thing that no manuscript will be submitted or printed without letting it through a machine to be sure that it's safe in the future. So that's all I want to say about plagiarism, and I'm moving on to the main part. And in this, and also a little bit then here, I will give you several examples. And the first one, rather detailed, because we are chemists. We can have a look at this. 20 years ago, ETH Zurich, there was a PhD thesis on high resolution photoelectron spectroscopy. It was actually zero kinetic energy photoelectron spectroscopy that the person did on small radicals. Submitted 1999, 2 papers resulted from it, and a couple of years later the first reports came in from other labs around the world who could not reproduce the results. So in the group that he had worked in, they tried to reproduce the results themselves. This is very sophisticated technology. And this poor person here, Gasser, he tried to reproduce the spectra shown in the red there from the thesis. And you see in the region, in the spectral region here, where there are 2 prominent peaks, he found nothing. This was suspicious. So the ETH started an official inquiry. And this was done by the physical chemists. It was done very well. And here I give you an example out of the report. Because some of you are spectroscopists, this is interesting. The investigators, they took 2 spectra of 2 different compounds and put them on top of each other. And what we see here is we see a very noisy spectrum, or noisy spectra. We see a peak in one of the spectra, a peak in the other one of the spectra. But what we see immediately, and some of you have spotted it, is the region outside of the peaks, this region here. this region in between and this one here, they're coincident. And this cannot be. Noise is a random phenomenon. If you measure the noise twice, you will never get the same pattern. You see that? I hope you see that. That's why I chose this example for you. So obviously, at least one of these spectra was not measured, but constructed. And we can see how. Let's assume the red one was measured. And then this part here was taken out and replaced by some green invented noise. And this noisy part here in the red was taken out and replaced by a green peak. He knew where he wanted to have the peaks. Or it could have been the other way around. But one of the spectra obviously was constructed and invented. And we can even go back to this. Maybe some of you have seen it. You see the noise pattern here and here is identical. That's utterly impossible. You can't get this. So clearly, the guy had manipulated his data. He had falsified his data. So the committee went to have a look at the lab notes that every student has to leave when he leaves the group. His lab notes were conspicuously missing. And then they got in touch with him. He had a good job at the bank. That was 10 years after the fact. And they confronted him with the evidence. And he acknowledged that, yes, it's manipulated, but not by me. Now, I must tell you this is a shortcut that I'm giving you here, because at that time, I already had my job in Bern, so I knew my colleagues in Zurich. The guy actually first conceded that he had done the manipulations, but then he talked to a lawyer. And the lawyer advised him to deny any involvement in any manipulation. And he then stuck to this. The ETH decided to revoke his PhD title anyway. And against this, the attorney, of course, appealed. It went to the courts. Oh, yes, it went to the courts. It went all the way up to the Supreme Court of Switzerland. And the decision there was the ETH had the right to revoke the title. So far, so good, we could say, but it's not quite so. First of all, we should realize that once a case is in the hands of lawyers, scientific integrity is in danger. A judge, he does not know much about zero kinetic energy photoelectron spectroscopy of small radicals. So his decision will not be based on the scientific evidence, which is overwhelming. It will be based on some argumentation of lawyers. And that's why the attorney of the defendant in this case, he has an interest to move the case away from the scientific evidence onto the legalistic level as soon as possible, as far as possible. And there anything can happen. A little slip by the ETH lawyer, formal slip, and the thing goes down the drain. Or the ETH may lose its interest and drop the case. I actually learned just recently that this was the case here. The ETH was prepared not to pursue it to the end, and it was the PhD advisor who happened to have money, who wanted to clean himself, who employed lawyers to pull it through. So once it's in the hands of lawyers, beware. Now the noise pattern was also relevant here, and some of you have heard of this case that was big in the newspapers. Jan Henrik Schön, PhD in Konstanz in Germany, and then postdoc at the Bell Labs in the US. And there he soon started to publish astounding new results. And at quite a sequence of about every 8 days, he published a paper, many in the highest ranked journals. And well, it didn't last very long, but about 2 years until it blew up. Most of it fabricated. But the Bell Labs, they set up a committee. And here I'm just showing you again, since you're scientists, I'm showing you again 2 figures they took from different papers, put them together, and you see the data are the same. You see the same noise patterns here. What is plotted is the drain current against some voltage here. Once it's for alpha-6-thiophene, and one is for perylene. It cannot be. 2 different compounds cannot have the same drain current. And so it blew up. He lost his job at the Bell Labs. Many papers had to be retracted, and here I just have a list of the Nature and Science papers which had to be retracted. Only Nature and Science papers in 2000 and 2001, Schön et al., 13 pieces. And of course the question is, how could this happen? We probably all know about the rigorous review procedures in these renowned journals. And I remember reading the answer to this question in an editorial by Donald Kennedy. He was at that time editor-in-chief of Science. And he wrote, "We have failed. We have been carried away by a hype. Our review procedures were relaxed because we were afraid he would send it to Nature and they would publish it first. It must not happen again." These are the words of Donald Kennedy, editor-in-chief of Science. So, you know, these 2 journals, they wanted to be the first to publish these unbelievable results. Okay, I think there's a lesson to learn from this one. And I'm now coming to the last part where I will give you another few examples. Obstacles. I give you an example here. Again, well-known newspapers. There was a person, this Diederik Stapel in the Netherlands. I don't know whether anybody has heard or read of that case. He was a very well-known psychologist, and he had some ideas about human behavior, some theories. And since he was an experimental psychologist, he devised questionnaires which could be used to question the public and then find out whether the theory had been any good or not. So the students usually went out, collected the answers. He also helped in this. Usually on Monday morning he had a bunch of questionnaires that he gave the students to put in the computer to see whether there was statistical significance. And this went on for several years. It went on for several years until the student or the students became suspicious. And then they were starting to look at his answers, the answers that he collected. And they found that they statistically significantly deviated from the rest of the answers. And of course, the suspicion is that he did not question any people. He filled in the forms himself. And that's what they also did. They saw that his answers, they were always pushing the statistics a little bit towards his theory. I hope you're with me. All right. And to come back to this point, it took many months from the time the students were sure that their boss was cheating until it blew up. And I think it's quite understandable. Here is a big professor, big reputation, lots of funding, lots of papers, a big man in the faculty, and here you are, graduate student, dependent on that person. You want a degree, you want references. You think twice before you go to the university administration and denounce him. They may bounce you and not him. So you want assurances before you take that step. You want perhaps to do it with your colleagues. And you want to be absolutely sure that you're correct. So I think that is an activation barrier which is obvious when you have these dependencies. But I think there is another, in my opinion, there is another aspect. Namely, if you work in a group with your colleagues on similar subjects, similar projects, you also have social activities, you do things together, you go to Tarke or whatever, and that creates sort of a group identity, corporate identity, if you like. And it's not easy to denounce your colleague or your boss because he's part of that group. So I think these two factors may have both added to an activation barrier which created a delay of almost a year until they really went. And he lost his job. He conceded it. He conceded it, yes. And I think more than 50 papers had to be retracted. He lost his job, and from my Dutch colleagues, I hear that he's doing quite well now. He's giving talks on scientific integrity. So he has first-hand experience. Okay, now I'm coming to the next point. That is a case that I had to deal with when I had that job in Bern. I was investigating a case of alleged multiple data manipulations in many papers over many years by a person at that time employed at our university. That's why it came to me. Now, this person, he denied any wrongdoing from the beginning, and he took an attorney to defend his interest. And this attorney, the first thing he did is he changed my part. He said I was a prosecutor and not an investigator. And as a prosecutor, I have to prove beyond doubt that his client did the manipulations himself. Now, if I was a prosecutor, not an investigator, I would have means. I could confiscate the computer, I could get the court order to get my hands on the original data, things like this, but I didn't have any of this. So there was a clash of systems with me on the short end of the stick. What I badly needed were the original data. You know, if you have, in a publication, if you have pictures, there were lots of Western blots. If somebody knows what Western blots are, lots of Western blots, images, which were under suspicion. So what I asked for, what I demanded officially, were the original experimental data. Then I can compare, and it would be relatively easy to see whether manipulation had been done or not. Well, the attorney and his client, they were smiling at me. They were saying, unfortunately, no original data are available. And I was licked. I was licked. My university could not give me instruments to counter this. What I could do is, we still had a case because some of the manipulations had been clumsily done and we could prove them, but that was circumstantial evidence. The other one would have been direct. So my sad conclusion here, there's also a little bit of frustration in the statement, as you can imagine. We spent 700 working hours on this case, 700. The sad conclusion is that it's too easy to get away with it. You manipulate data or falsify data, you deny it, stick to your lie, and refuse access to the original data. You can also destroy the originals. Now, this is not a recipe for you people, it's more an expression of what I felt or what I concluded from this case. Another case, again, manipulated experimental data, but in this case we had the originals. A person who had been a postdoc at our university for a couple of years had done the work, a paper had resulted, and then again other people couldn't reproduce the result. But the originals were still at our university, so we could compare the published and the original data. And it was very interesting. He was measuring a quantity which had quite a broad statistical spread. So there were points like this. And what he actually did, he removed all the lower ones. He removed points from the lower end of the distribution, and he added some on the upper end of the distribution. And by doing this, he shifted the average a little towards it was supposed to be according to his theory. And so we got in touch with him. In the meantime, he had become a professor in another European country at a university. So we got in touch with him. We confronted him with the evidence. At first he balked a bit, but then he had to concede, yes, sure. The thing was retracted, and again, we could say, so far so good. Again, I wanted a bit more. In my report to my rector, I said our university should inform that European university about the background of their cheating professor. But nothing doing. I got a letter back from my board of directors of our university. They could not do that. Volunteering such information to that other university would be an infringement on the personal right of that cheating professor. So they could not do it. I felt, I was not neutral. I was an advocate of scientific integrity, so I felt they were weighing things not in the right way. Here you have these personal rights, which are important, and here it's a scientific integrity. But obviously for our lawyers, these personal rights, they were weighing more heavily. So I decided to do it on my own. I didn't feel bound by their decision. Because I had asked them to do something, they didn't want to do it, so I did it myself. I called the ombudsperson in this other university, told him, explained the situation, told him everything, named the person, and also offered him to send him all the documentation if he wanted it. But a better way would be for his president to send an official request to our president that they send the documentation. And that's what actually happened. Our university was prepared to act on this one because it was official. So it went there, and then nothing happened. I don't know how the situation is now. I called them. I called my ombudsperson again after 2 years, inquiring what has happened. Has anything happened? He told me, well, this person is still a professor here. And he also indicated very clearly that he did not want any more phone calls from me. So that was the end. As I said, I don't know. I would guess that he's still a professor. But I would like to leave a question to you. You know, I acted on my own in this case by informing that other university. Was that right? Did I have the right to do this? That's a question. I can put it slightly differently. Some of you may sometimes be in a committee to select a new professor. If you are, and you have had 70 applicants, short list of 6. My question is, would you like to know whether one of these 6 has a background of manipulating his experimental data until they fit the theory? That's my question to you. And with this, I have in principle finished, but since I have a few more minutes, yes. I mean, that was the conclusion from these cases. It's a learning process. I was the first scientific integrity officer at our university, and Eugenio mentioned at the beginning, anything like this doesn't exist here yet. And in Switzerland, all the universities have this position now, but as we saw, both at the ETH, also at the University of Bern, it's a learning process. We are not there yet, in my opinion. So let me just give you one more. Aha, yes, I'm ahead of myself. You know, in the case of Schön, for instance, or also Stapel. Well, Stapel, the university acted, but in some cases, it's the main pressure does not come from the institution itself. There are some obstacles within the institutional, but if a misconduct has happened within the field, it spreads immediately. We have at the moment a young professor at the ETH again, who is even being supported by the ETH, who has manipulated lots of data. The ETH is supporting him, but scientifically, in the community, in the international community, he has had it. So there's more pressure from the peers than from the institution. Now I just see whether there's another one before I... No, I just want to mention a book. I've read this book recently by Naomi Oreskes and Eric Conway, Merchants of Doubt. It's very readable for anybody who's interested in this kind of subject. It's very well recherché, and it shows that in many cases in the US, scientists were involved in decision-making on high levels in a way which we do not consider proper at the moment. And I can give you one example. It's just a recipe on how you can do it. Take cigarette smoking in the 1990s, US. It was well known that cigarette smoking is causing lung cancer, but the tobacco companies, they got away with it for the following reason. It's very simple. A man dies of lung cancer. He has been smoking 3 packs of cigarettes for 20 years. At the trial, the widow sues the tobacco company for damages. At the trial, I'm there as a scientific expert. The attorney of the lady asks me, is it scientifically established that smoking cigarettes is causing lung cancer? The answer is yes. And then the attorney of the tobacco company asks me, can you scientifically prove that her husband died as a result of smoking cigarettes? You know the answer. No, no way. The judge, the jury, they're confused. First he says yes, and then he says no. The problem is the general public is not familiar with the statistics, with the laws of probability. We can make a statement concerning the ensemble, but for a single case, we cannot prove it. And that was the problem. You know, the courts, for many years, the courts were ruling that they were acquitting the tobacco companies in these trials because you would have to prove beyond doubt that the man dies as a result of smoking cigarettes. And then, a few years later, they started to change their attitude, their rulings. But in these few years, the tobacco companies, they made many billions of dollars, and thousands of people died. So if anybody is interested, it's not a bad investment, this book. And the recipe is the same. Global warming everywhere. And the point is that this question, can science prove that this man died as a result of smoking cigarettes? That question did not come from the attorney himself. He doesn't know anything about this. It was inspired by a scientist that they had hired. Only a scientist knows this distinction that I have been mentioning. And there were a handful who were involved over decades in various fields, always in the role as urgent. With this, I leave you. Thank you very much.
For this, this talk that is usual from the point of view of science, but is usual from the point of view of life. Yes. Then, have you any comment, question? Yes?
You talk about very clear instances like data manipulation, fraud, but there are also, in my case, so these kind of manipulations I never experienced, but there are other cases that I think are also inside these problems of insights, for instance, about authorship. I think probably you have also many issues about students that complain that they should be in a paper or in a work or about the order of the authors. So I don't know how it's, also for me, myself is sometimes not clear what is to be an author. And I don't know if in your position you have maybe a more clear view what is an author.
Yes, look, I had to restrict myself here to some cases. But authorship, who is an author? What responsibility does an author have? Questions like this were the most frequent coming to me. I give you my definition of who an author is and who isn't. An author is someone who has made a significant contribution to the work. And no author is who has not made a significant contribution to the work. So, honorary authorship, for instance, a professor, a clinic director, and things like this, he will not be an author even if he is directing the institute or the clinic. He will not be an author because he has not contributed scientifically to the work. Concerning responsibility, I give you again my definition. There are many definitions. Mine is the best. An author, co-author, is responsible for that part of the work which lies within his area of competence. You find all sorts of definitions, but this one I think is pretty good. Every author should read the paper, and in the area in which he's competent, he can evaluate it, he can judge it, and he can make contributions. But there are many cases nowadays, collaborations, theoretical parts, experimental parts, where you can't expect somebody over here to be able to really take responsibility for that part. And the last point is the order of, and also the who is the corresponding author. I have talked to several people, and I have seen this as a touchy subject here. I didn't realize it. Apparently, the corresponding author is very important. First of all, the order. Alphabetical order is all right. That's objective. No problem. You can put alphabetical order. And then another often used order is the person who did most of the work comes first. Maybe the one who did almost as much work comes second. These people come first. Very often the leader of the team, if it's only one team, comes last. So the first spot, the second spot are important, and then of course the corresponding author or the corresponding authors. And there are no clear-cut rules about this. That's really up to the authors to decide who should be the corresponding author.
And depends on the field. I think in physics and chemistry, it's a little different.
Well, look, take it. Sorry, I'll come to you. But take high energy physics. Do you know how, if they do an experiment at the CERN, they do an experiment at the CERN, it leads to a Fitzreflector or something. And a graduate student has worked, 20 years ago, has worked to develop a detector component for the Atlas in the CERN. Well, that was part of his thesis. He should be an author. So they have developed their own rules. They have consortia. I don't know whether there are any high-energy physicists around who know probably know much about it. As far as I know, there are consortia, and the people who appear in the author list are not all the ones who have contributed, but all these other ones are listed somewhere. You must correct me if I'm wrong. But anyway, so in some fields they have to develop their own rules. And concerning corresponding authorship, again, who should be or who shouldn't be, that's not clearly defined. It will vary, it will depend on the authors. They have to sit together and decide this. That's how much I can say about this. But it was the main subject in my job, that's clear. But I didn't want to go into this, it's getting touchy. Excuse me.
First of all, thanks for this very nice talk. And I think science needs people like you. You have mentioned several examples, few but significant examples of scientists who have cheated, who have been lying. And you have put all the weight on this side. I mean, certainly they are guilty. But I also wonder, in this responsibility, what's the part corresponding to the rest of society, the scientific community? Because as everybody knows here, we are subject to a pressure to publish a lot. So maybe the temptation just to fake, to present fake results can be to some extent due to this pressure. I am not, of course, saying that they have no responsibility at all, but in order to have a complete view of the situation, in order to avoid this, one should somehow to think about how to change this state of the mind for people who are so much pressed. And I would like to know your opinion.
Yeah, that's a difficult question. You know, this pressure to publish, how can we do anything about that? it's self-inflicted, you know, the science community inflicts it itself. It's not coming from outside, I think, because all the committees making selections of people, they want criteria and they look at the publications. I can only say now, in the Swiss National Science Foundation, they're not allowed to just take publication list or impact factors. All these things they're not allowed to use anymore when they evaluate a proposal, because they know that these are not really the important and relevant things. They can be important. They force the evaluators to actually go and read some papers and not just look at the impact factor or the number of papers. I have no recipe about this. Maybe I can also say that, you know, people ask me, how widespread is this cheating? I don't know, because it's very hard. I only saw the tip of some icebergs, but overall still, the tips of icebergs that I see compared to the number of papers which are being published every year, I mean, it's 1 to 1,000 or 1 to 10,000. So I think we are, overall, we are quite an honest community. I would be interested to know whether anybody has an idea about what he's asking. I think it's a serious question. You know, this pressure to publish. Because we're inflicting it on ourselves. I mean, the community is inflicting it on itself. Why? Maybe it's to simplify the world. You know, if you have an impact factor, you have a number, and if you have a number, then you don't have to read the paper. You know, in an evaluation process, it's so much simpler for some selections or for some evaluations to just it's Nature paper, that's great. We should become more honest about this and say we can only evaluate the paper by really spending a day trying to read it, or half a day, or at least 2 hours, instead of just taking these stupid numbers. Was this on the film? Yeah, okay.
I am worried when I read about these problems, and I fear that we only catch the very lazy people, and I would like your opinion on what's the proportion of very lazy cheaters compared to medium-skilled cheaters who do not copy the same figure twice. Because everybody has enough data to use unpublished data, and I'm afraid that people are only copies, so these Western blots are good, are well-known examples, but also these figures that you show. If you use the same data twice in publish, then it's obvious that you are not doing it with a medium skill. But I wonder whether all cheaters are lazy, or because peer pressure it's hard to do it right, or whether we are only just seeing the very less talented cheaters.
No, I don't think they're particularly lazy. I think if one could make statistics of them, it would be just people like you and me, like the average. You know, they're very clever cheaters and very lazy cheaters. And, so I don't think it's the lazy one. But I mean, you're worrying about the other 90% of the iceberg, which we don't see. Now, if you're in a field which is hot, in our area of science, there is a likelihood that what you publish will be checked by somebody who's trying to reproduce it. Not in the CERN experiment, they have a monopoly. Nobody else will repeat the experiment, nor do you. Do you repeat something on Atlas and on the other detector?
Sure.
To be sure.
CNS and Atlas.
CMS, okay. See, even these guys, billions of euros are invested to make sure that they can reproduce it. But also in other fields, I mean, the two cases I mentioned, they came to the surface because somebody could not reproduce the results. So there is hope that this happens. Now, what else did you ask?
No, yeah, I was wondering about this because I also think that not very many, in proportion, not very many works are reproduced. Like the super interesting stuff, yes.
Yes.
But the regular stuff, I think we have this pressure to publish that there is a gigantic bulk of things that are published and nobody looks at them twice. And I don't know whether, I mean, I suspect that the only solution can come from peer pressure from within the same room. That people check, okay, what are you doing? Because I think if somebody is like medium skill and just uses noise from an unpublished experiment, if you don't go to Nature but to, you know, Inorchem, then not many people are going to go to the trouble. Okay, maybe they suspect, okay, maybe they didn't give all the details and then I'm not able to reproduce and then I just renounce.
Yeah. I mean, there is one thing we should not. It's important that we don't that we distinguish between misconduct and making mistakes.
Yes.
You know, misconduct is a willing act to deceive your audience, your readers, but making mistakes is part of our daily life, and this will also lead to non-reproducible results.
Then you have a question?
Yeah. Thank you, Hans, for the talk. I think every time it's going to be more difficult to find these manipulations because every time there are more and more journals, more and more articles, and the referees don't reproduce the experiments. So I think it's an important issue for the scientific community. And what do you think about the responsibility of the editorials? Since, as you show, there are a lot of examples of retracted articles from Nature and Science, but they have still the perspective of the journal.
Yes. Well, sorry, could you repeat the first part of
it was just a comment about that every time there are more and more journals, there are a lot of articles.
Sorry.
So it's difficult.
You know, I said plagiarism is a transient phenomenon because that can be dealt with easily, cheaply. Now with figures, with images, we're going from kilobytes to megabytes. So it almost gets to big data. If we want to check an image which is being published with the internet, I'm not aware that such a software exists, but I think it will exist because for me this would have been very, very helpful in my case where we spend so much time to have a software comparing an image with what you find in the internet. This is feasible. It's expensive, but I think this will be done. Now you're saying it will be more difficult because we are expanding all the time. Yes?
And about the responsibility of the editorial?
Yeah, okay. I think you should ask yourself if you were an editor, what would you do to improve or to make sure that you don't publish anything that's not...
Maybe pay the referees.
Pay?
Pay referees. Maybe.
Pay the referees.
To reproduce some
What was
experiments.
that idea? Is that a majority that thinks that's a good idea?
But a couple of weeks ago, we made a report about these problems in the Biophysical Society here in Spain. And it seems that there is a majority of people in favor of that.
Paying the
And it
referees.
actually seems that that is part of the problem. The peer reviewing system is not, it seems that it's not anymore suitable for science. It's like a,
There is an alternative. You know, the very well-known scientists have proposed to do away with the peer review and use a kind of Wikipedia principle that you just put everything on a platform, and then the peers can come and correct it. That's another idea which has come up. I've been out of science for 10 years. I don't really have any opinion on this. Francisco.
Francisco?
So these issues, what journals are doing, actually, and Levante Chemie is doing is giving prizes to best referee of the year. There is a professor here in Valencia who got this prize for many years, so this can be also a possibility. Well, turning back to the question of, I saw you very optimistic on how the percentage of people cheating. There is maybe for this concept, it's a concept also of unconscious cheating, which is related to the mistakes. Mistakes, okay, it's not so, from the moral point of view, it's not so, you cannot punish this or pursue this legally because it's a different thing. But mistakes can be also considered as unconscious cheating. Imagine you have this spectrum, this spectrum with two peaks. It's not invented, it's not done, it's not corrected by a software. It's just experimental. But the second peak is not true. It comes from an impurity, or it comes from many other things. As your knowledge of your field increases, you could devise many different ways of explaining these second peaks. But if you are hurried, let's say, by the pressure of the environment, which is also involved, the pressure to publish, and your knowledge is poor, so as you have more increase the pressure of publish, and your personal knowledge on the field decreases, then you are not going to find, or you're not going to find a person who is going to advise you on the nature of this second peak, and then you will publish the wrong result. So this is why I am not so optimistic, and I think there's a lot of cheating in science, and it's something that it's very difficult to
Well, actually, you have not been talking about cheating. You have been talking to publish things without checking them properly because you're. It's the same subject as the gentleman in front of you.
But if you do it voluntarily, if you don't take the time, you're professional. I mean, if you're a professional, you should take the time to do this properly. So if you don't take this time, you're cheating. Unconsciously or even consciously. This is...
Yes.
Well, may I add something? Sure. Not only pressure of publication, but pressure of success, scientific success. I remember about 20 years ago at the University of Valencia, there was very good news, new invention, the water engine. And there was a conference at the university without checking if this was against the second law of thermodynamics, for instance. And immediately the news spread out, actually in public television, Spanish television, and it was a shame. And this is because even the University of Valencia was very much interested in having this success in the world.
Yes.
And so it is generally what I was referring to was the general pressure for success. Publication is one of these aspects. And this, I think, we should be aware because maybe the level, as he was saying, of just checking things is lowering, and we are more, in favor of accepting things because of our interest, even without exactly cheating.
I agree, and I think it's up to each one of us, but especially responsibility are with those, maybe you're a leader of a research team or you're a leader of a big research team. I think it's up to you to enforce, to make sure that in your group that that level that we had 20 years ago is retained. Because I mean, the young people, they have to learn this, and I think the group leaders have a responsibility there.
More questions? Yeah.
I had really some bad experience with reproducibility of some biological stuff. Like during my postdoc work at Güdel Institute, I tried to reproduce, and then I could not actually. Then I wrote to that husbanding author, and then he told me that since you are new in this field, so it might take some time to get all the stuff and do it properly. So for me it was like really difficult. Either they were hiding that procedures, what they have published, or I was really inexperienced to this field to reproduce. So can you comment on that?
Oh dear. I would look for the most expert person around you here and try to involve him to look at this. There are people with a lot of experience with magnetic data or with the sort of materials that you are working with. I would consult these and sit together with them and then take a decision.
So it's hard to take immediate any decision, like according to you.
Yeah, I think you have to really spend time. So the original advice of the person that you need more experience and maybe more input from others, I would support this.
Well, more questions about this discussion? Because we're in a discussion table now. Yeah.
This is, I don't know, may sound like a criticism. I think that you put it like an ethical problem. Like the solution is at once. And I think that behind this there is a system problem. That the system is not anymore suitable for today's science. So my question is there any movement or any idea about changing the rules of science?
The system, you mean the science system?
The whole system, publication system.
But in science, not
Yeah.
including politics?
No, science.
Okay.
Although it might be linked to other problems.
Science system, but you're part of it. I was part of it. You're all part of the science system. So everyone has a responsibility, and you can start an initiative with your colleagues and say we have to change it. I have told Eugenio recently, you are now an influential man. Use your influence to have an influence on the system. That's what I told him. It will not change from bottom up. It has to change a bit top down, I think. Because, I mean, what can a student do to change the system?
But I mean, apart from these individual movements, I mean, for example, in America there is an institute of meta-science.
Of meta
Meta-science that is involved in revising. I don't know exactly how they do. They just pick randomly papers and analyze everything. So, but this is not enough. It only exists there in Europe. I know of any similar thing. Or people like you exist in your country, but not here in our universities, not in the other countries' universities. So what I mean is, can we do something more general, like changing the rules of the whole thing, not just individual?
Well, I don't know. I'm skeptical that another agency in Brussels or whatever in Brussels would be a good idea. I mean, you mentioned the difference. In Switzerland, every university has an integrity officer who is independent of the administration. That's important. I told you the example where I acted on my own. Everybody in Switzerland, so that happened about 10, 15 years ago that we started. In Scandinavia, they're much further than we are. These issues are more important up there and have been for a longer time than in Switzerland. But I noticed that in the Mediterranean countries, it takes a bit longer, I think, to establish. I mean, just the position that I had would be a start for a university. I think yours is very big, so it might need more than one person. Ours is a very small university. Would be a start if enough people think that's important. So you could start at this university, together with some colleagues, start an initiative to establish a scientific integrity office. I would not wait for Brussels. I wouldn't go for Brussels. I would start here.
Yeah, here the problem is always the same. You have administration versus scientist. Then it depends of which one is having the power. Then the scientist should take the power for this kind of initiatives, not the administration. You should not expect that the administration is giving you this kind of solutions. It's from the scientists that should appear. In Spain, for example, the problem is that the administration is controlling a lot. The agency that is going to be created now, instead of putting a scientist as a boss of the agency of research, now is an administration person. Then we are fighting and trying to remove this person, but it's impossible so far. You see, there is always, and in the university is the same. Well, we want to create this kind of initiative, is up to us, not up to the administration. The administration, yes, for them, they are not going to do anything.
But probably in this country, there exists like a law that obliges every university to have a person like that.
No way. It was individuals who took the initiative.
Individuals, yeah.
It started in medicine because they had the biggest problems, and they still have. And so a few medical professors, they started in the Swiss Academy of Medical Sciences. They started this. And then the universities came next. A couple of years later, the universities came. Our regulations were more or less copied from the medical ones first, and then we had to change them. It's up to individuals to take initiatives and to put the thing on the table, make it public, and put and pressure and make some pressure.
Yeah, but as you said, then you don't have the tools to do anything. You discover someone and you cannot. So that doesn't seem to be the solution. That is
sure. That's why I said we still have a way to go, but I'm positive that we will go that way. We are not there yet, but at least I think the awareness that this subject has a value and is important is increasing in Switzerland. We had the discussion, how can we teach the students? And there have been proposals to have a first-year course in ethical pedagogics or something like this. Forget it. I believe it's much better to do it on the level of these people, master students, PhD students, where you can use examples to demonstrate to them that they can feel that this thing is important. But a formal talk about ethical pedagogy, I don't think anybody is interested in this. So in Bern, this happens. Not only my job at the university, but some graduate schools within the university, they require everybody to work in the graduate school to have a 2-hour introduction to scientific integrity. But this was all initialized by professors at the university.
Okay. The message is clear as well. Then, if there are no more questions, we can thanks again.